Greetings and welcome, internet friends. Here's a slightly different video than normal. I'm teaching some tech tools today, as well as getting students ready for an upcoming online assessment. And so today I'm teaching how to use the tool Equatio right here. And the way you access it, I believe, for my students anyway, I've already shared out how you can find it, but yeah, go to chrome.google.com, type the word Equatio, install it to Chrome. It'll give you a little icon right up here. And if you're one of the students in my school system, you already have access to the full version of this. There are some little tutorials. They've got a YouTube page as well. You can check that out there as well. So the way we're going to be using Equatio today is in a Google form for one of our tests. And this is actually a practice test on our radicals and complex numbers unit that I pulled from a whole bunch of stuff. And one of the things I've done is added notes to kind of how you can access some of the tools in case during the test you forget some of these features. So if I was trying to simplify the negative square root of 54, yeah, you could try to type things in here, but that's not the way we're going to want to do it. We're going to want to click on the Equatio icon and click Insert Math. And what that's going to do is open up this bottom bar right here. And there's all sorts of fancy stuff. You can link to your phone. You could text to speech. That's probably not a good idea. You can even do handwriting recognition on your phone, linking the answer to this. I'm not going to recommend any of that today. I'm going to recommend just the plain old equation editor. And so if I open this, let's see, I'll scroll down so we can still see our problem. This is where I can start typing math stuff. And so I'm going to try to type the original problem. And so to get the square root, notice it says simply write SQRT. And so while in the Equatio window, I start typing, and notice it's actually giving me a whole bunch of options. So if I wrote out the whole phrase square root, that would work. If I type SQRT, it eventually identifies that. I could either click on it or hit enter, and I get that problem. Now, to type out my work so that I can give partial credit to you, so that way you're not simply giving me an answer, I'm looking for the work. Notice I can move the cursor to the side, and if I hit enter, now I'm on a new line. There are a whole bunch of formatting features as far as how these lines work. I can insert a new column, insert new rows, things like that. We'll tinker with some of those in a moment. But right now, square root of 54, if I want to simplify that, because the index is the invisible 2, I'm going to find the largest perfect square that goes into it, which is 9, right? And so notice I have to hit over again to get another square root, and 9 times 6 is 54. You could enter things like multiplication using Shift 8, right? You can do things like that. I believe there's also like different kind of, yeah, you can go back to regular text if you were doing a text answer. But I believe the keyboard's going to be the friendliest option for us. And so I'm going to hit enter again. The square root of 9 is exactly 3. Square root of 6, final answer. And this is when you hit insert math, and what it's going to do is it does a little bit of magic. It technically converts this to an image, and now I can see your process, just like if you were doing the math on paper, and I can give you partial credit, which or hopefully all credit, right? Obviously, yes. Okay, so here's another problem. So here's and this, by the way, is not a full example of the test. This is just some sample questions where this tool needs to be used. Now notice when I clicked on this again, it remembered my previous work, so you can delete that. And I'm going to type square root, and so notice 3x shift right 6 will give me an exponent to the 5th to get. If I hit divide now, notice I'm actually inside the exponent, which for this moment isn't helpful. If I go over too far, then just the radicals in the numerator. But oh, I got it just right with the entire fraction being inside the radical. And then I hit over and enter, and now I can do a new line. And so up in the top, I'm going to have the square root of 3. I'm going to break this out. You don't have to write multiply every time. Now x to the 5th, remember when simplifying, I'm going to try to write that as the largest exponent that is divisible by the index. And in a square root, the index is an invisible 2. And so I'm going to have an x to the 4th times square root x to the first technically, but we don't have to write that. Right, x to the fourth times x to the first would give me x to the fifth. And now I hit, oh dear. Now if I hit divide, the slash, I can have square root of 2 in the denominator. So what I've done is a few things, and actually, here's another trick. If you want to see more of your math, you can drag the 3 dots part there. I've distributed the square root over all of the terms, and I've begun to simplify the x to the fifth. Now, one of the things you might remember is that, oh no, we've got a square root in the denominator, and I can't leave it like that. And so this is where I'm going to have to multiply by some version of 1, and in order to do that, I'm going to use this new column to the right thing. And so if I just type new column, it technically has these invisible looking table sort of cells right here. And so if I'm going to multiply by a version of 1 that's going to get rid of this radical in the denominator. And so it's going to be square root 2, divided by square root 2. And so now if I hit enter, I can work on either side. I think that's the only time I'll need the right-hand column here for us. So let's see. Let's multiply across the top. Square root of 3 times square root of 2 is square root of 6. Square root of x can't be simplified. And the square root of x to the fourth, I'm going to be able to simplify to being x squared on the outside. And in the denominator, not enter, I got to hit divide. Root 2 times root 2 is plain old 2. And there's my final answer. I've got the radical out of the denominator. All the things inside the radicals are fully simplified. Hit insert, and notice it documents all the math. I'll be able to figure out how to grade that there. Let's see. I guess I'll make the video as long as you guys are willing to watch if you want to learn all the tricks and get the practice with the math, I suppose. So here, 2 divided by, notice this, it says you may need to use open parentheses and divide in order to get a separate fraction beside the one given, the given one. Blah. So if I type square root of 3, I notice I hit, instead of -7 where I'm inside the radical, I went over in that. And so here, I could do, I think I could, I can't do the right-hand column yet until I hit enter at least one time. All right, see, there you go. I'm learning stuff too. So I'm going to hit column on the right. You technically could have done this trick as well, but I'm going to multiply this by a fraction, and the thing I'm going to multiply by is the conjugate. So I'm not multiplying by root 3 over root 3. I'm not multiplying by root 3 minus 7 over root 3 minus 7. I'm multiplying by the square root of 3 plus 7 over the square root of 3 plus 7. All right. And if you wanted, you could put these in parentheses like so. It doesn't technically matter. You'd be able to have that all figured out. Notice I can, using my arrow keys, kind of switch between these two columns now. Across the top, I've got to distribute. So that's going to be 2 square roots of 3 plus 2 times 7 is 14. Yep. Hit divide. Oh, wait a minute. That's not giving me the fraction I want. So what do you think I need to do? Well, I could go to the front and write parentheses. I think, will it let me if I do close parentheses here? Look how clever that is. It assumed by doing close parentheses, it was going to include that whole thing in the numerator. Now, for multiplying these two conjugates, it's going to become the a squared minus b squared pattern is what ends up happening. And so, well, you wouldn't have had to write it this way, but technically this is what's occurring. And so the a would have been the square root of 3 here. So square root 3. And the b would have been the 7. Making my Minecraft villager kind of noises again. Notice I ended up just copying and pasting, Control-C, Control-V to get that whole thing again. And I'm going to just simplify it from here. So root 3 squared is just plain old 3. Plain old 7 squared is 49. Let's see. So I copied and pasted. 3 minus 49 is negative 46. And, this problem ended up being, I think it's trickier than the one on the test. So couple things. I can simplify the 2 and the 14 with the 46. I'm also going to bring the minus sign up top. So the numerator is now going to all be opposited, which makes them all negative. And let's see, between 2, 46, and 14, they're all divisible by 2. And so 2 goes into itself once, so this is just negative root 3. 14 divided by 2 is 7. Hit divide. Not doing the thing I want, so I do parentheses divide. And, what did I already made another mistake. This is a minus 7, because I had to opposite everybody. And now the denominator is positive, and I'm dividing this 46 by 2 as well, so everything not in a radical had to be divided, and I get 23. And now I hit insert math, and yeah, it's long. It might take a minute to load. All that, you could do that. And technically, I believe you can go back and edit these things as well. Like sometimes the edit math button sort of thing will work as well. Let's see. I'm not... all right, keep wanting to be like, this video is getting too long. I'm just going to skip this. Let's see, delete that. I'll do the whole video. Because some people might want to see the examples. So skip around if you want, but here we go. So here I've got cubed roots. And so there's a couple ways. I could write cube, and notice I can get cube root. I can also type nth, and I could get an nth root, and I'm showing you that. And notice using my arrow keys, it looks like left, right is how I get between these. I could make this the cubed root of 20 times, and let's see, what if I do it this way? Oh, those do look this, and this is still editable. Oh, that's awesome. Okay, I don't know which is faster, typing cube or nth, but whatever. Here we go. And so I'm multiplying those two things. So now I'm going to get the cubed root of 20 times 6 is 120. And I believe I can simplify this. The largest perfect cube, all right, because this is a cubed root, the largest perfect cube that goes into 120, I believe, is 8. And how many times does it go in? 15 times. And so I'm going to type in cube root of 8 multiplied by cube root of 15. Cube root of 8 becomes 2 times the cube root of 15. And I hit insert, boom, donezo. It's got all my math. It's a lovely day. All right, last and trickiest problem. Here we go. Reviewing the math. Let's see, why isn't it letting me scroll right now? Okay. Oh. All right, there. Oh, because it's the last problem. It won't let me scroll below it. That's annoying. So let's see. Root 2x plus 6x plus 3. All right, here we go. Here we go. So square root 2x plus 6 equals x plus 3. Now, in order to solve these kinds of problems, first thing you do is get the radical by itself, isolated on one side of the equation. That is done. Then I'm going to tell you what. Let's copy and paste. I'm going to square both sides. And so notice if I close parentheses here, I can square that side. If I close, it got a little too bold. So I've got to do open parentheses there and then square both sides, not at sign. What is this? Okay, square both sides. So this side just becomes 2x plus 6 equals, by the way, the equal signs, notice they are not lined up. There are technically some ways that you can align it to the relationship. Let's see. I'm afraid I've never done this after the fact. Yeah, and so notice it kind of lines them all up. What it's technically doing is just kind of making like 3 columns. I don't know if that's any prettier. And actually, I also don't know if I can hit Control Z. Oh, I can. I'm just going to leave it this way. I'm not too worried about that. Let's see. So, all right, I'll write out the pattern. So a squared plus 2 times a times b. What did I just do? Did I just hit enter too much? I don't know. I deleted it somehow. Plus b squared. So 2x plus 6, oh dear, equals x squared plus 6x plus 9. And notice what I'm left with is a quadratic, right? It's got an x squared term. And in the only way at this point my students know how to solve quadratics is by setting it equal to 0 and factoring. If you want to write something like subtract 2x from both sides, you can. I'm going to trust that my Algebra 2 students know some of these tricks. I'm just going to jump right in. So I'm going to have x squared. 6x minus 2x is 4x. And 9 minus the 6 becomes 3. Technically, this is 0 equals that. I'm going to flip it around as well at the same time, and I get the following. Now, factoring. If you guys have already done a test on factoring, you're probably okay. But if you want to show your list of factors of your C term here, you could do the enter the right column and do 1, 3, and there aren't any others in this case. If you want to do that, you can. So I'm going to have an x with a 1 times an x with a 3 equals 0. Their signs are going to be plus plus. And so, oh dear. Whoa. What am I doing? What am I doing? Boom. All right, so I've factored it. It's set equal to 0. Using zero product property, I set each factor to 0 and solve. And actually, this is a point where I could use my two columns. I could have x plus 1 equals 0 here, and x plus 3 equals 0 there. Over here, I'd get x equals -1. Here, I'd get x equals -3. All right. Now, technically, I don't know if these answers are extraneous. And, all right, there's, oh boy. Okay, I can use arrow keys. I can't scroll when I'm inside here. It's weird. So since these answers could be extraneous, I do have to do a check. And so, tell you what, if we really wanted, I could even make regular text appear. So here's a check. I'm gonna check both of these. So everywhere there's an x, notice I just copied and pasted those things. I'm gonna plug in a -1. Everywhere there's an x over here, I'm gonna plug in a -3. Hope you guys are doing all right, by the way. Hope you're having a good day today. And now I just PEMDAS this. 2 times -2, no, -1 is -2, plus 6. Is that equal to 2? Is the square root of 4 equal to 2? True. So therefore, this is a solution. Nice. Over here, and notice I can move my cursor. So let's see. Square root of 2 times -3 is -6. Plus that other 6 equals -3 plus 3 is 0. Oh, okay. Notice, when I hit enter, it actually like wanted to add a new line. So using my arrow keys, it's all right. The formatting, you'll get used to it. And if yours doesn't like get formatted exactly beautifully, it's okay. So both are solutions. If one of them ended up not being a true statement from the check, then you could have like, just typed and notice, because this is math, it's like all confused and italicized. If you want to get it to just be text, you can click the text button. You can also type the word text, hit enter, and then you could have typed something like extraneous, right? But in this case, it wasn't. Oh dear, what did I just do? Okay, my control Z's were like really confusing me. All right, it just like shifted where everything was. So this is like this super long math problem, the craziest it can be. I hit insert, it would take a moment to think, and look at that. It's got it all fit in there. It's technically made it an image, but now Mr. Waddy can go and give you partial credit on your work. All right, so I hope this has accomplished two things. One, you got some practice with simplifying radicals, complex numbers, solving radical equations. Two, you learned how to use Equatio so that then on the test, I'm going to give you partial credit, right? If you just give me answers for these, I'm going to have to start taking away points, and I don't want to do that. So yeah, definitely show me your work. Yeah, the same kind of work that I've been doing in the notes, or we would have done if we were in class face to face. All right, thanks for watching, everybody. Have a good day.